coefficient, at the ends, I'm going in the same direction and both up, positive, yep. So the picture would look something like that, right? That's what this is doing. But as far as properly writing it out, again, I'm giving you lots of training wheels right now. That won't be there on the test. As x goes to the left forever, g of x, my y value goes positive infinity, up forever. As x goes to the right forever, my y value, g of x, goes positive infinity, up forever. Okay, so this is all going to have to be provided by you going forward. Okay. Real zeros. I take a look at my terms that have an x in them, including the first one. So my real zeros not only would be -1 and +2, but I hope you included 0 itself. Good. If you didn't, remember, anytime you have an x as one of your factors, that could equal 0, which could produce an x-intercept.
Why is it not 1?
Because when you actually set y equal to 0 to find x-intercepts, you set each factor equal to 0, and if you let x plus 1 equal 0, you move 1 to the other side. It becomes negative. I'll show you. If you let x equal 0, that's one of them. X plus 1 equals 0, and x minus 2 equals 0. You set each equal to 0, and that's how we get this.
Oh, I get it now.
Cool. Yep, so that's how we get each of them. Okay. All right, even if this was x to the 5th power, 6th power, that would still produce 0, wouldn't it? Okay. All right, so now multiplicities. The multiplicity of this guy is 2, which is even. The multiplicity of this guy is 1, which is odd. And the multiplicity of 2 came from this factor, which is 1, which is still odd. Even multiplicities, I touch or bounce. Odd multiplicities, I cut or cross. And then with that information, I could then begin my sketch. So I go down to my picture, with my end behavior going up at the ends in both directions, and these x-intercepts I could begin. So a real 0 at the origin, at -1, it exists there, and at +2, it exists there. I could even get a y-intercept just for kicks and giggles, to have a better sketch, which is usually a great idea. And the way we get y-intercepts is by letting x equal 0. In the original, we had y equals x squared, x plus 1, x minus 2, right? If I let x equal 0, that term goes to 0, doesn't it? So we're really fortunate when I am looking for a y-intercept and I have a term in front with an x, or an x to a power. That is going to be my y-intercept of 0, isn't it? Because the only way, if I let this be 0, the whole thing dies, doesn't it? So it doesn't matter that I get a 1 here and a -2 here, it's still multiplying by 0. Okay, so my y-intercept, you may have already seen that, right? That was the y-intercept. It was right in front of us. But I wanted to show you that you could have found it that way as well. Okay, so what next? I would look at my end behavior to continue. I know that at the ends, the degree was even, and the leading coefficient was positive, so they were going in the same direction and both up. So at this end, it's going up, and at this end, it's going up. Then in the middle, I would talk about what's happening at each x-intercept, right? At -1, that's this one. At -1, I'm crossing, aren't I? At -1, I'm crossing because his multiplicity was odd. So I have to cross here. I just have to remind myself. So I'm going to touch it and go through. Touch it and go through. At 0, which is coming next, its multiplicity was even, so I'm going to touch it. So I'm going to touch here. So at some point, I have to turn around. I come up and touch and turn around. And at 2, its multiplicity was odd, so I have to cut, don't I? So I'll cut. Now, how many turns could I have had? Good job. My maximum number of turns is the degree minus 1. The degree here was 4. 4 minus 1 is 3. So I could have up to 3 turns. Now, I know one of them happens at that turning point because it touches there, right? So that's one of them. But another one is implied to happen somewhere here. We don't know where, but we know it has to turn around because it was going down and then it has to go up. So there's one turn somewhere down here, which calculus 1 will tell us where. There's another turn here, so that's my second turn at the x-intercept where I touched. But then it's implied that I have to turn around at least one more time, don't I? And this has to be actually the only other time because that's our third attempt of turning. So here at some point we'll have to turn again if we're going down, and then we're going to have to be going up. So where we turn we don't know, but we know we're turning again somewhere. Okay, so you don't have to be perfect about where those turns are yet, as long as you show me a turn somewhere down there.
You don't have to know that until class 1.